on it.
Oh.
What you guys say doesn't...
So I have to talk louder?
No.
You can hear.
Okay. All right, so we are going to find geometric probability. So let's just first start talking about what probability is.
Why can't you take notes?
What does probability mean?
It means how many out of...
The possibility of something happening.
Right, the possibility of something happening. So, like if you have a bag full of marbles and...
2 blue, 1 red, and 2 yellow.
Right. So if you have a bag of marbles and there's 4 blue and 1 red, what's the probability that you picked out the red marble? 1 out of 5. So there's a total of 5. Okay. So the probability is the number on top is how many possibilities there are of that color or of whatever you're looking for. And the number on the bottom is always the total number. That's the same idea with geometric probability. Geometric probability, though, we're going to view it as area. So geometric probability, the number on the top will be the area of, we'll just call it the shaded region, but it's of whatever desired region you want it to land in. And the denominator is the total area. Okay, so when we're looking to find the geometric area of something, we have to find 2 different areas, the area of the shaded region and then the total area of the figure.
Is that over total?
Yep, over total area. So, for example, darts are thrown at a circular board randomly. Okay, so it's not by someone who's an expert, but they're just randomly thrown. Okay. We want to know if the dart hits the board, what's the probability that the dart lands in the bullseye? Okay, so where's the bullseye?
Right there.
It's right in the center. So we want to find the area of the bullseye. And then we divide it by the total area. Okay, so in this case, what type of shapes are we dealing with? Circles. Okay, so the bullseye is a circle. The large area is also a circle. So the area of the bullseye will be pi r squared with the radius of the bullseye. So what's going to be the radius of your bullseye? 2. Right there, it says 2. So the area of the bullseye would be pi times 2 squared over, now we need the total area. Well, it's not just 4, because the radius of the whole circle would be all the way out. So 2 plus 4 plus 4 is 10. So over pi times 10 squared. What would happen to these pi's? They'd cancel, and then we'd have 4 squared, which is, 2 squared, which is 4, over 10 squared, which is 100. So 4 hundredths. So 0.04. What would be the percent of that? 4%. Is that okay? All right. So that's our way how we're going to find area or find the geometric probability. We can also have the probability of a sector, okay, which is just a part, of it. So we first have to talk about the area of a sector. So I'm going to call that n degrees in there. And this is really just, it's like a proportion. Okay, so this is just a certain part of the circle. So how many total degrees are in a circle? 360. So the area of a sector would be how many ever degrees we have that's being covered over 360. And then we would times it by the total area of the circle. So it's n degrees over 360 times pi r squared. Okay. So that's how we would find that area of a sector. Now finding the area of a segment, this is a segment. What's different about that? It's a little smaller. So if we wanted to find the area of this segment right here, we would have to take the area of the sector and we would have to subtract off the triangle. That would give you the area of the segment. Okay, so there will be some problems where we will have to find the areas of the segments. So you'll have to take the area of the sector and subtract off the area of the triangle.
Wouldn't that be added to the triangle? Or are you talking about the white triangle?
The white, we'd have to subtract off this white triangle here. Because the sector would be this whole section.
And you add that part.
And then we would want to subtract off that white triangle, and that would leave us with just that segment, just that shaded area.
And you add it to the other triangle.
Yeah, if we had that other sector over there. Mm-hmm.
Okay.
All right, so let's try one. Here we have a regular hexagon. It's inscribed in a circle with a diameter of 12. We want to find the probability that a point chosen at random in the circle lies in the shaded region. So we have a hexagon that's inscribed in a circle with a diameter of 12. We want to find the probability that a point chosen at random lies somewhere in this shaded region. So we have to take the area of the shaded region over the total area. The shaded region, we don't know, we have to find it. But this is like our segment. Okay, so to find that area of the shaded region, we have to do the sector minus the triangle. And then divide it by, what's going to be the total area here? Not the hexagon, it's the circle. Then we're going to divide it by the circle. Okay? Well, to find the area of the sector, we need to know what that central angle is. Okay, so how are we going to find that central angle?
360 divided by 6.
Good, so we'll go 360 divided by 6, because there's 6 sides, is what? 60 degrees.
So aren't all three angles 60 degrees?
Yes, so we have an equilateral triangle. So the sector then is your angle, so 60 degrees over 360 times pi r squared. So pi times, what's your radius? 6 squared. Minus. Now we need to find the area of the triangle. I'm just going to take this and rotate it so we can look at it a little bit closer. If this is 12, what's one of the side lengths? 6.
And it's equilateral.
And it's equilateral, so all sides are 6. And so we need the height. Because our area of our triangle is 1/2 base times height. So we have the 1/2 and the base is 6. We just need the height now. So the height, well, if that's 60 degrees, what would the... Well, this would be a 30-60. Otherwise, here's your other choice. 30-60-90. So if that's 6, what's that small segment? 3. So then what's the height? 3 root 3. Okay, or you could have used sine, cosine, or tangent to get there. Okay, so there's our sector minus our triangle, and then we have to divide that all by our circle. And how do we find the area of our circle? Pi times 6 squared. Now, when you put this in your calculator, you have to be very careful. This whole top section needs parentheses. And the whole bottom section needs parentheses. Without it, you will not be able to find your area correctly. I'll give you guys a little bit here to get it.
That's the answer?
No, I'm waiting for you to get it.
Well, mine's not like that.
0.0.
Oh, no, I got it backwards.
Ooh, try again. Parentheses around the whole top, parentheses around the bottom. You should get 0.028, which we would just say is 0.03 because we normally go to the nearest hundredth. Try again if you did not get that. Okay? Of course, when you take your quiz on this, showing me that setup will be worth most of the points. If you have that set up perfectly and just did something wrong in your calculator, I'm only going to take like half a point off. All right. Should we follow this one? Let's do another one.
We just skipped that.
All right. Find the probability that a point chosen at random lies in the shaded region. So, this one. See, we've got all these shaded boxes here. I'll make them a little bit darker so you can see them a little bit better. So to find the probability of this shaded region, we want to take the total shaded area and divide it by the total area. When you have boxes like this, what do you assume the area of each box is? Just one. Yep. So how would we find the area of that shaded region? Count them up. 1, 2, 3, 4, 5, 6. So I think there's 25 up there. Does it look like you have the same pattern here? Yep, so how many total? So there's 50 total that are shaded. Now over, how many total boxes do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times 10 is 100. So what would we write that as? 1/2 or 0.5 is your probability. Yeah. So some of them are, so 50%. Some of them are a little bit more difficult. All right, let's jump to one that's a little bit more difficult again. We just counted up the shaded, got 50.
And then count up the.
Yep.
When we do the probability, are we doing percentage-wise then? Instead of decimal, or do you want the decimal?
Decimal's fine.
I'm like my dad.
All right, so number 2, we got this shape here. What type of polygon do we have inscribed? It's a hexagon. Okay, so we are going to have to find the area of the shaded and divide it by the total area. So let's write out what we're ultimately going to do here. So now our area of our shaded is we have 2 sections. Okay, so we're going to have to take our sector and subtract off. Are we just subtracting off one triangle now or 2? 2. We're going to have to subtract off 2 triangles. And then what would we divide this all by? The circle.
Is this your number 2?
Yep. I just know we'll run out of space, so I moved.
Why 2 triangles? Why is that
2 triangles because we have two sections here that we have to subtract off.
Oh.
Okay, so we need to find that angle measure that goes with this sector. Okay, so each of these are 60, but here we have 2 of them, so what's the total angle measure? 120. So we would have to do 120 over 360 times pi r squared. So what's your radius here? Yeah, 5.5 squared minus 2 triangles. So 2 times 1/2. Now we need base and height. These triangles should be the same, so we can just draw one of them out. What's going to be the length of each side here? 5.5, we know that because that's the radius. So what's our base?
2 and 2/5. Or 2, yeah.
So the whole thing's 5.5. So this is 2.75. So then how do we get the height?
X squared 3, 2.
Yep, so 2.75 square root of 3 because we know it's a 30, 60, 90. So then over here we'd fill in, oh no, I'm going to run out of space. I'll go sideways. 2.75 square root of 3. And then the area of our circle would be what? Pi times, yep, 5.5 squared. Once again, the denominator needs to be in parentheses and that numerator needs to be in parentheses in order for this to work. So what did you get?
0.06.
0.06 is that probability. Is that okay?
So 6%.
Yep, so about 6%. We're going to do one more tough one. Okay, what type of shape is this? This is a pentagon inscribed in a circle. So now we have a pentagon. We will not quite have the luxury of doing the 30, 60, 90s. Okay? Oh, you should probably take the worksheet, guys. Don't
Don't be upset, it's a worksheet.
don't leave too fast.
I didn't read it.
There you go.
We'll fill it out.
Oh, I gave you 3. I'll take one of them back. Oh, that works. Okay. So, let's talk through how we're going to find the area of the shaded. So what are we going to have to do? Area of what first? Area of the sector. There's 4 of them this time, minus. How many triangles do we have? 4 triangles over the circle. Okay, so now how are we going to find the central angle for each of these if they're each pentagons? 360 divided by 5. So what would be that total degrees for the sector since there's 4 of them?
72 plus 4.
Okay, so 72 times 4 would be what? Okay, so our sector would be 288 over 360 times pi r squared. So what's our radius this time? 8.5 squared, yep. Now I have to minus off for 4 triangles, so 4 times 1/2. Then we'll draw a triangle out to help us figure it out. So we know that one of the hypotenuse is 8.5. Okay? We do not know that the base is this time because we don't have 60-degree angles all around. Instead, we had 72, so what would that angle be right there? So 36? Okay. So we need to find out what the height is, and then we're going to need to find out what this value is so that we can get the base.
Can we do tangent?
We could do, not tangent won't work here. Sine or cosine will work. So if we use sine, which one are we going to find? The opposite over hypotenuse, so we'll find x. So we can do sine of 36 is our opposite x over 8.5. How do we get our x alone? Times by 8.5. So what would we get there? And now I'm going to suggest that you leave 4 decimal places here to keep it as exact as possible. So 4.99617. Now to get the whole base, what are we going to have to do?
Multiply by 2.
Okay, so we'll take that times 2, and then that will be our base number. So our base number to 4 decimal places is what? Okay, so we'll fill that in for our base. Okay, now we need to get the height. So what function will we use to find the height? The height is adjacent. We have the hypotenuse, so which one is that? Yeah, so we'll do cosine of 36 is our height over 8.5. So how are we going to solve that for height? Yep, times it by 8.5. And what do we get for the height then?
6.8766.
Yep, 6.8766, so we will fill that in for our height. All over,
Pi 8.5 squared.
yeah, pi times 8.5 squared. Do not forget your parentheses around everything. Phew. And let's figure out what this is. What'd you get? 0.19. Well, I'm glad one of you knows how to use a calculator in here. 2 of you maybe. 3, I saw maybe 3 using calculators. And I saw a bunch staring. All right, is that okay? That one's a really tough one. Because we couldn't just do 30, 60, 90. We had to do sine, cosine, or tangent. All right, and then we'll get to a couple others here. Find the area of the indicated sector. Then find the probability of spinning the color indicated if the diameter of the spinner is 9 meters.
Okay then. Yeah. So, what?
So it's like one of those spinners that you flick around and you want to see if you can land it in the right spot.
So, isn't like one of those spinners from like one side, like the radius
Yeah.
of the circle?
So here, we want to land in red. So how many sectors over there have red?
2.
We have 2. We've got this one and this one. They're red. So how many total degrees do we have?
140.
140. So the area of the sector would be 140 over 360 times.
Pi 9 squared.
Well, that's the diameter's 9.
So
4.5 squared. So you do 140 over 360 times pi times your 4.5 squared, and what do we get for the area of that sector?
2.474.
24.7?
Yeah. Oh yeah.
Okay. So 24.7 meters squared is that area. Now, the probability, what would we have to do with that area? Divide it by the total area of the circle, right? What's the total area of the circle? What do you notice about the pi and the 4.5 squareds when you find? They just cancel. So when you're finding the probability, you just have to look at the angle measure. So you can just do 140 divided by 360. So the probability would be 0.39. Is that okay?
Wait,
There's no like unit or anything.
No, probability, there's no unit.
the probability of us getting is 39%.
Correct. Do you want to do blue or yellow?
Blue.
Blue. All right.
Blue.
Blue.
Say it louder.
So we got 2 sections in blue. So what's our total degrees for blue?
135.
All right. So the area would be 135 over what? 360 and then multiplied by?
Well, we don't have to do that, right? Oh, we can.
Yeah, we have to find the area and the probability. Okay, so that's the area, and then how do we get the probability?
Just take 135.
Right, because when we go for the probability here, we end up dividing by pi 4.5 squared, so those cancel for the probability. So we just have to do 135 divided by 360, and we get what?
0.375.
So 0.38 to the nearest hundredth. Is that okay? Goodness. 27 minutes.
And going.